Hello, welcome back PlayBASIC coders. Let's take a look at this portal concept demo. I mentioned it the other day in another video and a bunch of times in the past, but the principle on show here is that we have volumes, rectangles actually, and rectangles with shared walls can then connect to the ones that are adjacent to them. And this can go on and on and on. So we can follow those connections through to work out whether something is visible to us or not. So here's our camera. If you look closely here, you'll see the numbers on the ground represent the identity of the portal. So this portal here, this one region, is this area here. It has a border with 2 and 5. So 9 down here is where the camera is currently. We move forward. If we look at the edges here that we're sharing, 9 has a link into 8. So if we were pointing back this way, it would follow, it would link from 9 into 8 and then down through the chain along these shared walls. That's the primary concept. So these regions here, we've got a bit of code to work out what are shared regions. So what other areas does 9 link to? If we're starting from portal 9, it has there's a doorway into 7, there's a doorway into 11 and 12 and 8. So there are 4 possible ways we could go. We could leave region 9 to move into the rest of the world. And up here you'll see it's looking at starting from region 9. It goes, okay, there's a region 7 that borders this, and to determine whether we should follow that through, we are just doing in this case a very simple detection of whether this doorway, we'll call it, is in front of the camera. It's in front of the frustum. If it is in front of the camera, we go, okay, we'll add this to the list of regions to be searched next, and then we repeat the process down through that. So it's recursive, but I'm not actually using recursion. I just have a stack of regions that we need to search next, and we just keep searching those things until we've exhausted all of the possible locations if we need to, or if we've come to a room that has no other exits, no other doorways out of it. Like if you're up here, for example, if we're in room 6, and we're pointing upwards, there's no doorway for me to actually see, so I can't leave this room. So that's all of the things that are visible from this location. Let's move the camera roughly back to where we were. I haven't clipped the camera either, so I'm just using this view here all the way through. So every time it compares with a new doorway, it's always using that. What it should really do is it should narrow down that visible, we'll call it an arc. It's like a triangle really in 2 dimensions like this. And then we should check if the doorway is either inside the triangle or intersecting the triangle. If it is, we follow it through and we keep checking down to regions that meet that same criteria. Now I've added another limitation here too, is if a portal is too far away from the camera, so this region 8 here, this border on 8 into 9, we can't see 8 because that's deemed as being too far, even though it is in front of the camera, so we're just rejecting that. Now it's been added, but we can't see into 10 or into 13 because these are shared with 8, because they're deemed to be outside of the view radius. And that's pretty much the meat and potatoes. It's pretty straightforward and simple, but the idea is that once you've got a list of what volumes that are actually in front of the camera, then we can go through and do, all right, let's put this region here into the 3D pipeline and draw the stuff that's inside region 9. So dynamic objects too, we could check whether they are in region 9, region 12, region 15, and if they are, we could pass them in, and we could go, all right, are you in front of the camera or not? So we're making another sub list or a short list of things or work that possibly needs to be done. But the whole goal here is to try and avoid overdraw as much as possible. Yes, well, there's a good example. We can see both because our view volume here isn't being clipped by these intersections here. So it thinks we can see around the corner. I think one way of eliminating that would be having the direction of this intersection. So when I'm walking out of, when I'm in volume 15 or portal 15, and I see there's a doorway, a window into 15, into 10, I can check the direction of this. If this is in the direction of the viewer, we can make an assumption that that's in view. If it's not, if it's a doorway like this one up here, then it wouldn't be in view, and as a byproduct, none of these things here would be in view. So you could use that to eliminate whether that portal is actually visible or not. You shouldn't be able to see 13 because in order for 13 to be visible, we have to have 8 be visible. So in this case here, the view frustum should be clipped to this camera size here, and that would stop it. But you know, it's just a general idea of what you might do. Even though it's simplified, we get a situation where we never really have to render the whole environment. Down here's a good example. And a walkway. I've got no collision in this demo, so I'm sort of hovering around where we need to be. If you look at the ones here with 0, that means there's no portal. There's no visibility at all. So if the camera was inside the wall, which is what this green area here is representing, then there would be nothing in view at all. So the code is a little convoluted, but the principle is what we need to sort of internalize. Our portal is storing the region on screen, the top left coordinates and the top right hand coordinates of this rectangle or square volume. And then each volume has a number of volumes that it's adjacent to. So if two volumes share a wall, the pre-computing pass will make those connections. That's necessary for when we're doing searching. So we want to, if we're in portal 1 and portal 1 links to portal 2 and portal 2 links to portal 3, then we need to know where we need to attribute that linking process, which is what the rendering or the pre-pass does for that little world down here. Here I'm just manually adding the zones. So as you can see over there, this would be portal 1, portal 2, 3, 4, 5, 6, 7, and so on. Just because I wanted to have something to test the demo, to see if does this work or doesn't it work. What this here does is when we add the portal, we've just added its rectangular area, and then we go through next and compute what portals link into what other ones. And so in other words, what portals have a shared wall. That's what we're doing. Here I'm painting this onto a secondary map, so I can just then look up this coordinate to see what portal this tile in the map represents. Again, just so we can take world space into map space and grab the portal index of that thing very quickly. No effort whatsoever. We're running through our portals, grabbing the area, converting these to, we're grabbing an area that one tile to the left and the top, one tile to the right, below and above, below and across. Because we want to draw a rectangle, the outer part of the rectangle, we don't care about the internal part of the portal. We're assuming that that's going to be empty, so we don't need to see if there's any bounding boxes there. We are skimming along the top line or the bottom line, That's what these checks here are doing. If it's a top line, we are checking, is there a bounding portal above us or below us? So in other words, are we, from our current room, are we linking into a room that's above us? In that case, it would be the axis that we're aligned to is the top of the portal, or is it the bottom? So are we leaving? Is this a portal that we're leaving the current room in below us? Are we linking into a room that's down the screen on this map? Adding it to our little child list, and horizontally we're doing the same thing. We're just going, well, but we're only checking the left edge and the right edge. And the process is this: we check the map. We make an assumption here that anything that's not a 0 is a wall map. So we're kind of thinking of the world as being a Wolfenstein 3D world, that we're going from raycasting into polygons. So we need a way of eliminating the polygon overdraw and those things cheaply. That's the idea of this anyway. We grab what portal, if any, exists. If it's the same portal, we just ignore it. If it's a different one, we add this as a child of the current one. So our current portal has a series of links that link to the shared, that have shared walls with the current one, and they all do all the way through. So, and that's the process. That's the creation process. The rendering part really is the other part that's interesting, or it's probably even simpler. So in our main loop, update the camera's logic, clip it to a particular size so we don't wander outside the map too far. Draw the map to the screen so we have something to visualize this whole thing with. We're calling this is done in two passes. We do a visibility test from, in this case here, it's the player's position and orientation. And then we're displaying what rooms came back as being visible from that position in space. So you could actually use the same thing here to do the visibility from other characters in the world to other objects. If you have multiple players, can player 1 see player 2, or can player 2 see player 1? In other words, are they in a portal that's visible to both of them? If they are, they're potentially visible. It doesn't mean they're exactly visible, but they're potentially visible. All right, check it out, dudes. Want to be quite sure. So we're drawing here. We're just drawing the fast room on the screen. A triangle to represent the fast room. That's all that does. We're clearing the list of visited portals. So that's to prevent this idea of the routine getting into a circle. So because if you deal with linked lists or linking in general, sometimes what can happen is you end up with, let's say you've got two nodes in a list, and node 1 links to node 2, and then node 2 links back to node 1. That's an infinite loop. So we want to prevent that. So we just go, well, have I been to this portal already? If I haven't, we look at it. If I have, we ignore it. I've got a list of portals to be searched from now on, actually. So we're adding the initial starting portal and setting our size, and then we just sit in a while loop and pass through it. We grab the portal index at the top of this stack, this portal search stack. We check, have I been to this portal already? If I haven't, we look at it and we find any child nodes that it attaches to. If I have, we ignore it. We don't need to do anything with that one. We've already searched through that one. So if this is an area that we haven't been to, we go to find the connected windows. Here I've turned them windows. That's how I think of it conceptually, is that these shared empty spaces are like windows between one room and the next. It's like an empty space that's a shared volume that I'm just terming as being a window. So for our current portal, we go, give me an array of all of the shared portals that are or the child portals that are connected to our current portal. So what are the shared or connected other regions that we can exit this room and go into? We grab that shared places map location, we look at its axis, we compute a physical location in world space of where this portal is going to be. We do a quick rejection test on the distance from this doorway or this window to the camera. If it's too far away, we just reject it. Go, don't worry about searching from here, which in turn then eliminates searching through that portal and any sibling portals it has. So we're just culling out whole sections of the map by just doing a quick test. Here I'm just doing a frustum test, just with polar coordinates actually. I'm just going, give me the angle between the camera and this particular edge, and going, are we in view? Yes or no? And then, is the other side in view? Kind of a simple test. We could probably should really do as in a point in triangle test here, or there's a couple of situations where those things where you need to do more elaborate testing, like when it's possible for, if you have a line and a triangle, it's possible for the line coordinates to be outside the triangle, but the path of the line passes through the triangle. So that's probably a better way of doing this, to ensure that we get all the little edge cases are cleaned up in that process, to make sure we're determining whether something's in front of the camera or it's not. But this is good enough for the test anyway. I'm just drawing this edge space on screen. If the window is connected and visible to us, we grab this connected, the index of this portal we're moving into potentially, and adding it to our list of places to search next, and bumping the count of places to search. That's it. That's the entire process. It's a bit, it's not the best implementation, fair enough, but as a raw concept, that's pretty much all you need to know. Hope that's of some value. Hope that's triggered some thoughts and some ways that you can implement this stuff. Here we've got our alignments to a grid. It wouldn't have to be. Like, we've got volumes that are rectangles here, but the geometry inside that rectangle wouldn't have to be actually just boxes. It could be anything inside that. But we've gone through and zoned off what areas are connected and what areas are not. Anyway, thanks for watching, and I'll see you next time. Bye.